I'd ask you to consider, first of all, not just Northern Ireland, or even the island of Ireland, but also the European context. Northern Ireland is just a microcosm of what's happening in the rest of Europe. And when we look at the issue of renewable energy and the amount of renewable energy, the penetration, if you want, onto power systems, and what is the answer to it, we see that there are a number of strands to the answer. We talk about demand-side management, and I think we can all understand how that might help. We also talk about storage systems, and of course that can help too. And big interconnections. And it's been mentioned on a couple of occasions that interconnection will be helping on this island in terms of the penetration of renewable energy. At times, EirGrid tell us that the power system can be 50% wind during the summer minimums. And they limit it to 50% wind because they haven't got the solutions yet that they need to bring it to what they want to go, where they want to go, which is 75%. So that's what EirGrid say, and Sony say similar things. So, but in the European context, what we're talking about is, and we call it the supergrid. And the reason that we need to do it, the reasons are quite clear. We're not going to dwell on things like sustainability and security of supply. It's been mentioned that wind is about the only natural resource that we have to power the energy system of the future in Ireland, but it's not that much different in Europe. If you look forward to 2050, our estimations are that renewable energy needs to be about 80% of the power system. And that will be, in the main, because it can be delivered at scale, and starting today, offshore wind, some onshore wind, and solar in the south. Or even in North Africa, but that may come a little bit later. So these are the kind of things that people are talking about. And we're not alone talking about it because there's numerous reports now. Everybody says big interconnection is good. Everybody says that if you have an offshore wind industry, that you need to interconnect it. So we shouldn't be building single point-to-point interconnectors anymore. We need to start interconnecting all these networks together. So these are the kind of studies that are being done, and everybody says it will be cheaper in the long run. So we have to start planning for this. When we start planning, we have to start looking at top-down planning. What we have right now in Europe is individual countries putting all their plans together and then sending it into a central pot. And out of that comes the European plan with so-called projects of common interest. Our view is that if we really want to get it right by 2050, we need to start planning from the top down, and we need to start doing it now. And we need to plan for things like 80% renewable energy. So, when we start looking at the portfolio and what it might look like in 2050, with a large penetration of renewable energy, we start seeing how much renewable energy we need to install. It is variable, so it's not there all the time. So we need to have other processes, other technologies, and the ability to store energy, the ability to manage our demand, and of course we will have to have some other generation. There are times when the wind doesn't blow. It's actually not that often. And we've done a study over the last, looking at the last 50 years of wind in Europe, and the question was, is the wind always blowing somewhere? And the answer actually is yes. There are occasions when it's quite low, but they're very rare. So, when you look at the fuel portfolio, that's where you start. After that, then you say, well, if we're going to have all of this resource, how do we interconnect it together? And we follow that up with, what's the technology that we need to deliver that? Now, it has been mentioned that, and a number of people say that the technology exists. And in some ways it does. But I would say that it exists on the hard side. So, we know that if we have big, long interconnectors, we're going to have to start using HVDC rather than the AC networks that we are more familiar with today. AC and DC had a battle between Edison and Tesla, or Edison and Westinghouse, depending on to whom you talk, at the end of the 19th century. And Tesla and Westinghouse won. Edison lost. And the reason was because of the transformer, which allowed very cheaply and efficiently voltage to be changed. That's why DC actually lost. But in the 1930s, 40s, and 50s, HVDC technology started to be developed. It's a European technology, started in Scandinavia. But it was very much a technology push. So here's an idea. If you've got a lot of power and you have a long distance, under certain circumstances, it makes sense to use DC rather than AC. And here's a way to do it. And older engineers among you will remember that they used mercury arc rectifiers in these early designs. Today, of course, we have power electronics, and things have moved on. Some of this innovation has been delivered because the market is starting to pull. Offshore wind has made a huge difference in the requirements of technology, particularly in this space. We have longer distances to travel, and offshore wind, the networks are so-called electrically weak networks. So we needed a new HVDC technology, and it started to come, so-called voltage source. We have trouble building overhead lines. If we go underground, and if the price is coming down, then we're going to have to use more DC than AC. And that brings its own challenges in terms of control, in terms of operation, in terms of what the engineers in the power control center will call inertia. But just going back to offshore wind for a moment, there is another side to the technology development that needs to happen. Offshore wind is data intensive. If you imagine what an offshore turbine actually, if you look at all the data points, you can go from 15 to 20 meters below the seabed all the way to the tip, which could be at 200 meters. And at each point in that chain, there's a data point that is of interest to not only the designer, the operator, but the maintenance guy for the offshore wind. And today's turbines are going to be about 5 megawatts. So, 500 megawatts, that's 100 turbines. Each data point multiplied by 100, and then look at the amount of gigawatts. Now the amount of data starts to increase. So we need a new system to manage all of this data. We call it ISIS, but all it is taking the data in from all of these different points, putting them into models, and then delivering information and decision support to designers and operators. We talk about control systems. In a future with huge amounts of renewables, variable source connected ultimately down the chain to a variable demand requires a new control system. The HVDC networks that will exist in 2050 require a new control system. Doesn't exist today. Somebody has to design it. And how that links from a communications perspective and decision support to the downstream demand-side management, storage, distribution networks, all of that has to be designed. This is the opportunity. It's not just Northern Ireland, it's not just Ireland, it's Europe and ultimately the rest of the world. We're on a once-off transition to sustainability. We have an opportunity to build that future. And it can be built anywhere. Somebody has to do it. Might as well be here. Thank you.